Okay, so number 2 is talking about domain and range. Describe what domain and range are. Domain, I would say, is the x values for which a function is defined. So it's just where all the x values where the function exists. Okay. Whereas the range is the same thing. It's just the y values for which a function is defined. Okay. So then ditto. The y values for which a function is defined. I asked you to come up with a sketch and an example of functions with an unlimited domain and an unlimited range, an unlimited domain and a limited range, a limited domain and an unlimited range, and a limited domain, limited range. Okay, so, where did I put that piece of paper? Sorry, I'm trying to find my 12 functions because it'll make it a lot easier to explain it. Where did I just put those? Oh, right here. Okay. So as far as unlimited domain and unlimited range, unlimited domain and unlimited range means it goes left and right forever and up and down forever. This one goes left and right forever, but it does not go up and down. It just stays at 3. This one goes left and right forever, and it does go up and down forever. So a linear function would be an example. But that means basically like any odd power, because like look at this, a quadratic. It goes left and right forever, but it doesn't go all the way up. It has a stopping point, right? But then this function does, right? This cubic, it goes all the way to the left and to the right and up and down. So a cubic function would do that. So would a quintic function, so if you had something like that, right? So any of those odd functions. Um, Otherwise, let's see, like the exponential, or so the square root only goes so low and it only goes so far to the left. The exponential goes all the way left and right, but it does not go all the way up and down. It has a horizontal asymptote that it kind of levels off at. The logarithm only goes so far to the left, and the cubed root, the cubed root does go left and right, but it also goes up and down. It just kind of slowly. So another one could be, and you don't have to draw all of them. I'm just doing all the examples that you guys could have come up with. Cubed root, and the absolute value only goes so low. So these are the only 4 options really that you could have said for that for part B. Okay, for part C, unlimited domain but a limited range. So a limited range means it only goes so high but while going to the left and the right forever. So a constant function, a quadratic function only goes so high. A quartic function only goes so high or so low, right? So all the even. And then an exponential, it goes all the way left and right, but only so far up and down. And then an absolute value as well. So I'm going to draw all those. We've got the constant function. We've got a quadratic. We've got a quartic. We've got the exponential. And we've got the absolute value. So lots of different options for those. All right, let's look at D. A limited domain, but an unlimited range. Now there's only 2 on here that have a limited domain. Okay? This has a limited domain because it doesn't go all the way to the left, and this has a limited domain because it doesn't go all the way left. Now this one has a starting point, and this one starts at a vertical asymptote, meaning it's approaching it and getting infinitesimally close, but never reaches it. Okay, so limited domain, limited domain. But we were supposed to find an unlimited range, which means all the way up and down. This one only goes so low. This one goes all the way up and down, even though this is really, really slow. So for that one, we would say a logarithm is the only example. And then limited domain and limited range would be the square root. Now, I think for some classes we just said like a segment of a function, and that's fine. But the square root function is in fact limited domain and limited range. Okay. Now, let's let's talk about number 3. Number 3 says, what are x and y intercepts? So x-intercept, y-intercept. Okay, an x-intercept is where the function touches, that's, looks like I can't spell, touches or crosses the x-axis. Okay, whereas a y-intercept is where the function touches or crosses the y-axis. So ditto, 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 y-axis. Then it asks, how can you find x-intercepts? How can you find y-intercepts? So you can find these by substituting in, or actually, because it's the x value that you're trying to find when it equals 0, so what you want to do is set the function equal to 0 and solve for x. Okay, so set the function equal to 0 and solve for x. Or you might have written substitute in a 0 for y and solve, and that's the same thing as setting it equal to 0. Unless it's a different type of function. It could be an implicit function, but you don't know about that. Okay, y-intercept. So that's when you substitute in 0 for x and solve for y. Okay? So if I had an equation, everywhere there's an x, I'd replace it with a 0, and then whatever I'm left over with is the y-intercept, if I'm left with anything. Because you don't necessarily have to have a y-intercept, nor do you have to have an x-intercept. Which can you have more than one of, x-intercept or y-intercept? For the one you can't, why not? So if I think about a function, like crossing the x-axis more than once, that's absolutely possible. Okay, so I have an x-intercept there and an x-intercept there. And the reason why is because for every y value, you do not have to have a unique x. So the x values do not have to be unique. Well, okay. Per y value, the x values do not have to be unique. But in order to cross the y-axis more than once, I would have to, like, say I'm coming down right here, and then I would have to, like, double back, right? That's not a function because it doesn't pass the vertical line test. So I couldn't cross the y-axis more than once. So there can only be there can be only one y-intercept because each x must have a unique y. Okay? Because each x value must have a unique y value. And you could say the function wouldn't pass the vertical line test. Give an example of a function that does not have an x-intercept. Okay. No x-intercept. If we look at our graphs, this one doesn't have an x-intercept, so we could say a constant. Oh, I cannot write. It's been so long. So constant functions don't have an x-intercept. They don't have to. I mean, the only way you have an x-intercept is if you are the x-axis, in which case you have infinitely many. Crosses the x, although it doesn't have to, right? A quadratic could land above. So the quadratic could be like way up in space, and then it would never cross the x-axis. So quadratic is an option. But then again, that means so is every even-powered. So every even-powered polynomial. The transformation, like you could take a square root and transform it away from the x-axis and then known. The cubic, it's really important that you understand that linear, cubic, and quintic have to go. They have to come from a negative infinity go to positive, or positive and go to negative. So at some point they do have to cross the x-axis. Okay? Exponential. This one doesn't. have an x-intercept. Logarithm does have to have an x-intercept. Cubed root does, because I have to go from negative to positive or positive to negative. And the absolute value could be shifted out. So these are just some examples of ones that don't have an x-intercept. Alright, I think I'm going to stop this video and start over with another one, starting at number 4.